We're going to study scatter plots. And I don't know if scatter plots is one word or two words, so I use both. So this is also called linear regression. You may or may not have done a unit on linear regression in Unit 2, depending on your teacher and when you took it. Okay, so we're going to start with the vocab. A linear model is an equation of the straight line through the points on a scatter plot. So an equation of a line. We know what an equation of a line is, right? Let me turn on your mic and tell me what an equation of a line is.
Isn't it like y equals mx plus b?
Nailed it. Raise your hand if you've ever seen this equation before. And remember it from Algebra 1, Algebra 2. Calculus, equation of a tangent line. Those were just linear equations. Well, that's not enough of you that raised your hand, but we'll take it. Okay, I assume you've all, I know you've all seen the equation y equals mx plus b, where m is the slope and b is the y-intercept, meaning it goes through the y-axis at the point over 0 up b. We know it's linear because x and y are both to the first power. Just invisible ones on those exponents. And m and b are constants. They're numbers. Okay, to describe the association of a scatter plot. Well, let me quickly draw. So, scatter plots are always two quantitative variables. The linear model is also called the line of best fit. That is going to go through the points. Yes, I will post them, Ava. It's going to go through the points, and the way it's calculated is like the distance above and below the line will even out. So that's how they calculate where the line goes. You're not going to have to do that. We're going to do it on our calculators. Our calculator's going to do it for us. So to describe a distribution, we remember describing histograms. And we needed three things: shape, center, and spread. To describe a scatter plot, Aaron, do you have a question? Okay, to describe a scatter plot, we need three things as well. We need direction, form, and strength. And then the optional or as needed fourth one are outliers. If there are outliers, we must mention them when describing a scatter plot. So direction, meaning positive or negative. And we read graphs left to right. So the one I drew up here from left to right is increasing, so it's going to have a positive direction. The form is the shape that the dots take on. So mainly we're going to look at linear. There are also, so we're going to mainly look at linear and study linear, but they can also take on the form of quadratic, exponential, and a few others, but we're going to study linear. Strength means how strong. So scatter plots can be very strong, meaning its correlation is close to 1. So strength, let me start this over. Strength is determined by R. Strength is not an opinion. You can actually measure strength by R, which is the correlation coefficient. So when R is close to 1 or -1, it will be considered strong. It will have a strong correlation. R is always between -1 and +1. I'll define R separately here in a moment. Strength is determined by R. So strong, weak, moderate, those kind of adjectives to go with the direction. And outliers are mentioned if there are any. So remember, outliers affect some calculations, some statistics, and they don't affect others. For example, they affect the mean. They do not have a strong effect on the median. Okay, the correlation coefficient. is used there we go. Correlation coefficient is a statistic. It's a number used to determine the strength and direction of a linear model. So direction, because if R is positive, the association is positive. If R is negative, the association is negative. It'll have a negative slope, or it'll have a positive slope. The sign of R is the same as the sign of the slope. So R is always between -1 and +1. And it can be equal to -1 and +1. It's just rare to have a perfect correlation in real life data. It's easy to make happen. All you do is get a slope of 1, but it's rare for it to exist in real data. But being close to -1 or close to +1 is a strong correlation. So the closer R is to 1 or -1, the stronger the correlation is in that direction, positive or negative direction. If R is close to 0, there may be an association. Yes. Starting at correlation coefficient. Here. if R is near 0, then it's going to be a very weak correlation. And it won't be linear. It'll either be scattered, very scattered, or it could be quadratic. But it will not be linear if R is near 0. The closer R is to 0, the weaker the association is. So it's stronger. It's strong near 1 and -1, weak or no association near 0. Okay, we're going to go over to my math lab. Let me share this screen. Okay, you should be able to see my math lab screen. So when you log in, go down to Tools for Success on the left-hand side. And then the second one says Applets. Click on that. And then open up number 12. It says Correlation by Eye. So I'll do that all again. Log into my math lab. Go to Tools for Success. Right under Chapter Contents. Then you'll see Applets. Click on that. And then go open up number 12. Correlation by Eye. So you're going to change this from 20 to 100. And if you just watch mine for a minute, if you hit simulate, it's going to randomly generate a correlation, like scattering these 100 data points. So here, this is really going to be really close to -1 because they're tight, they're close together. The closer they are together, the stronger the association. The more scattered, the weaker. So then you're going to try to guess what the correlation is going to be. So I know this isn't exactly -1, but I know it's going to be close. So it tells me I'm within 0.1, and then you can hit show, and it'll tell you the exact correlation. And then you can do it again. This one's going to be close to 0 because it's all over the place. I'm going to check, and then it gives me a hint. Try a negative association. So -0.1 maybe. Try stronger, so I need to get closer to -1. So now I'm getting closer, and then you can hit show. So go ahead and do a few of those.